Good evening. Welcome to this session. And in this session, we will continue the solution for GATE 2017 Mathematics. It's a video from part 2. I hope you have watched part 1. So from 26 onwards, we will continue. Here you are given that U and V are null spaces of this matrix and this matrix. So they are asking for the dimension of subspace U plus V. Okay. So in order to apply this dimension of this subspace U plus V, I'll simply apply this formula. Dimension of U plus V is nothing but dimension of U plus dimension of V minus dimension of U intersection V. And if you notice, then they have given that this is the dimension of null space. Right, so U and V are the null spaces. So let's apply. Now, we want the dimension of null space. So how it goes, we consider it. Something's wrong. We see that this is a matrix of 2 over 4, and this is also a matrix of 2 over 4. That means the transformation from which this matrix is coming must be from R4 to R2. And let me not take U, I'll instead take TU. Okay, for U, and for TV, the transformation, it will be coming from R4 to R2. And now they need the null space of this matrix. So instead, we will take the rank and use Salvestri criteria, which is also called as rank nullity theorem. So instead of finding this big null space, what we consider, we just find the rank of this matrix. So clearly, the rank of this matrix is 2. Rank of this matrix is 2. So the null space will be again 2 because the rank of U is 2. Okay. Let me not write U because you might be wondering that U is a null space. So let me say, let me name this matrix in fact. Some U dash and this is some V dash. So rank of U dash is 2. Okay, that means rank of U dash is 2. That and dimension of U. Okay, it was 4. So what will be the nullity? So nullity of U dash will be what? 4 minus 2. So that will give me 2. And here I'm just using rank nullity theorem, and it says rank of U plus rank nullity of U. Okay, rank of U plus nullity of U gives me the dimension of the vector space. So here dimension of V is 4 and the rank of this matrix is 2. So nullity is automatically 2. All right. So now for the same ideology will be applied to the second matrix. It also has the same connection. So I'll simply say U is a null space. So that means dimension of U we found to be 2 because rank is 2. So dimension of U will be 2. Okay. And similarly, you can find out this dimension, a dimension of V. That means dimension of the null space of this matrix. So we want the null space of this matrix. So instead of finding the null space, I'll find out the rank of this matrix. So clearly rank of this matrix is again 2. Since the rank of this matrix is 2, so by rank nullity theorem, I'll get even the nullity to be 2. Because V is also coming from R4. So 4 minus 2 will give me 2. So dimension of V will be equal to 2. And now I want the this one I've got this one now. And all I'm worried about is this dimension of U intersection V. So we want the U intersection V. So consider U intersection V to be a matrix again, and just plug in all of them the way they are. Okay. So 1 1 0 0 0 0 1 1 1 2 3 2 0 1 2 1. What we do, we find the rank of this matrix. Okay, we find the rank of this matrix and then just subtract it from the dimension and we get the nullity because they want a nullity. Everything is based on the null space. Okay, null space, that means we want dimension of kernelity, which is nullity. So instead we will find out the rank of this matrix. So to find the rank of this matrix, I'll reduce this matrix to reduced row echelon form. So if I practice that thing, then I'll be getting, say I'll subtract this one from this row. So here I have 1 1 0 0 0 0 1 1, and I'll subtract 1 minus 1 will be 0, 2 minus 1 will give me 1, 3 minus 0 will be 3, 2 minus 0 will be 2, and here I'm happy. So 0 1 2 1, so nothing to worry. And now another transformation is needed. So I'll utilize this space and later I'll remove it. Okay. So I'll perform one more operation because it is not in the row echelon form. So 1, 1, 0, 0. Instead, I have to make this quantity to be 0. So 0, 0, 1, 1, 0, 1, 3, 2, and subtract this one from the above. So 0 minus 0 is 0, 1 minus 1 is 0, 2 minus 3 is minus 1, or instead, just hold a moment. Instead of making this a row 0, I'll simply take the advantage of making the third row 0. So that gives me 0 minus 0 will be 0, 1 minus 1 will be again 0, 3 minus 2 is 1, and 2 minus 1 is again 1. And last row remains the way it is. And now from it is clear that this row will survive and this will survive. And since these two are same, that means only one of them is needed. So the rank of this matrix, that means rank of this matrix. Let me not write U and V. Instead, I'll say rank of this matrix is 3. Okay, so rank of this matrix is 3. This implies dimension, that is nullity of U intersection V. Okay, since the rank is 3 and matrix is 4 by 4, that means nullity is just 1. So dimension of U intersection V will be 1. So now we got all of them, and all we need is just to plug in into this formula and derive what is the dimension of U intersection V, U plus V. Okay, so let me erase this one and just I'll simply plug in here. So dimension of U is again 2, and 2 minus 1 will give me 3. So answer is 3. All right, now go for this one. It says given two matrices A and B with entries in complex number. So consider the following statements. They have given two statements. That is, if A and B have same minimal polynomial, then is A similar to B? Yeah, that's fine. And if it is saying if A has n distinct eigenvalues, then there exists a U eigenvector. It's some kind of vector. We can't say eigenvector basically, such that though it will be an eigenvector by looking at this one. So such that U, AU, A square, U, and so on are linearly independent. So we have to say which of the following is true and which of the following is false. So if you notice, then A and B have same minimal polynomial. It is saying that if two matrices have same minimal polynomial, then are they similar? We know that the converse is same. Okay, if two matrices are similar, then they may have same minimal polynomial, but the direct part is not true. That means let's take A to be some 5 cross 5 matrix and take B to be 4 cross 4 matrix. And let's take the minimal polynomial of this matrix of A to be x minus 3 power 3. And minimal polynomial of B, you can take x minus 3 power 4. Okay. Wait, let me not take nilpotent matrix. X minus 3 power 3 again. So if you notice, then see, minimal polynomial of these two matrices are same, but I did not write here B. This is B. So minimal polynomial of these two matrices are same. Okay, but these two matrices are not similar because one is of dimension 5 and second one is of 4. Okay, so this statement is false. P is not true. For Q, it is clear from the definition that you have studied in your bachelor's. And if you have distinct eigenvalues, then there exists a vector U belong to C, and so that we know that AU will be equal to what? Lambda U. Okay. A square U will be what? Lambda square U, and so on. It will go on n minus 1 U to lambda n minus 1 U. Okay. Since all of them are distinct, so they have linearly independent eigenvectors. That means U, AU, and all of them. Okay. This one, this, all of them are linearly independent. So this statement is true. So that means P is false and Q is true. Okay. You can match the option. Now, look at this one. A very nice problem. It says A is your 10 by 10 matrix such that Aij is equal to 1. Okay. And the diagonal, principal diagonal, Aii, it is all alpha plus 1. So where alpha is positive. So let lambda and mu be the largest eigenvalue and the smallest eigenvalue. So such that lambda plus mu is 24, then what will be alpha? Okay. The problem seems to be quite tricky, but still we can solve it very easily. Just I'll consider the matrix first. Let me see if I get any idea. This matrix is going to be a 10 by 10 matrix. So though this looks bad. Instead, let me draw it using a proper tool. Yeah, so it's a 10 by 10 matrix, and we see that all of them everywhere it is 1 instead of this, except this principal diagonal. So principal diagonal is alpha plus 1. So let me write down all the principal diagonals by alpha plus 1. Okay, while rest of them it is 1. Okay, 10 times. Okay, so this thing will be followed. The rest of the all these entries are just 1. Okay, so we need to find out the eigenvalues for this matrix. So by this simple rule, if you know that, if you have seen, then just notice, suppose I get this matrix, okay, 1 plus 2 and 1, okay, 3 minus 1 plus 1, 3 and 4, 2, 4 and 0, 0. If you look at this matrix, then the sum of each row is 2 plus 1 plus 1, 4, 3 plus 2, 5 minus 1 is 4, and 4 plus 0, 0 is 4. That means 4 is one of the eigenvalues. Okay, 4 is one of the eigenvalues. So instead, if you look at this matrix very closely, then it says alpha plus 1 plus 1 plus 1 and so on. This will be one of the eigenvalues. But again, that will create a problem because we won't be able to find out the remaining eigenvalues. So what I do, I just perform one simple operation by writing this to be the addition of two matrices. So that makes it this. I'll keep this alphas here, okay, and I'll shift everything here now. All of them are 10 by 10. Okay. It's not transformed. Yeah. So this will be all just 1, 1, 1. And if you notice, then these two are same. And now we know that eigenvalues are additive. So I know all the eigenvalues of this matrix. Okay. So instead, I'll say that eigenvalues for this matrix are alpha, 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 and so on up to alpha 10 times. Right. Plus an eigenvalue for this matrix. Okay. This matrix is very familiar matrix, and I'll narrate it here. So 1, 1, 1, and 1, so on. Instead, not let me write 1, 1, 1. Instead, let me write down the most general one. Suppose you have a constant here, say some lambda, 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 a matrix filled with only one entries. Okay, all, say n by n. Then only eigenvalue. Okay, it has got n eigenvalues, but n minus 1 eigenvalues are 0. Okay, n minus 1 eigenvalues are 0, and only one eigenvalue is just how many times? N times lambda. So one eigenvalue for this matrix is n lambda, and rest of all of the eigenvalues are 0. Okay. So here I'll write down one of the eigenvalue for this matrix will be C. 1 is 10 times. So that means 10 is one of the eigenvalue, and rest of them are simply 0. Okay, 10 times. So I'll just add them. So that gives me alpha plus 10, comma alpha, and so on up to 10 times, right? So what it is saying that lambda and mu be the smallest eigenvalue. So of course, since your alpha is positive, since alpha is greater than 0, and this implies what? Alpha plus 10 will be greater than alpha. So this is the largest eigenvalue, lambda, and this is mu. And since they have given that lambda plus mu equals 24. So here I have alpha plus 10 plus alpha equals 24. That means 2 alpha equals to 24 minus 10, 14. This implies alpha equals 7. So the answer is 7. All right. And now let's solve this one from complex analysis. And it's complex integration, basically. So let C be a simple positively oriented circle of radius 2 centered at the origin in C, then 2 over pi I integral over C, z e power 1 by z plus tan z by 2 plus 1 upon z minus 1 into z minus 3 square dz will be what? Okay. So remember, in GATE or in any examination, if the term inside the integrand looks quite difficult, then consider that problem to be the most easiest one. Okay. So all right, instead of the integration, I'll perform Cauchy residue theorem because that looks easy here. So let's continue. The first thing that we need to worry about is it's a basically circle of radius 2. Okay, so circle of radius 2, just let me draw it here. Okay, let me draw it here, circle of radius 2. Okay, so this is my circle of radius 2. I just need to find out how many singularities are inside this circle. Okay, how many singularities are inside this circle? It's of radius 2, that means this point is my 2, 0. Okay, so I need to check how many singularities are inside. So this function has no problem, right? It seems to be analytic, or I think it has got a problem at z equal to 0. So yes, this function has got some problem. That's fine. We will check it. And for this function, z equal to 1 is a singularity. Okay, and z equal to 3 is also singularity, but z equals to 3 lies outside. Okay, it is lying outside, so there is no problem. So only z equal to 1 is the problem. That's fine. And for this function tan z by 2, this function is analytic. Okay, so we don't have to worry about anything. That means if a function is analytic, then we know that its integration over a closed contour C is always 0. Okay, that's by Cauchy integral formula. So we just need to evaluate this one and this one. So I'll use Cauchy residue theorem to evaluate these two integrals. Okay, so at z equal to 0. Okay, let me expand the Lorentz series for this function. Instead, we don't need to expand Lorentz because we can get the same answer even in Taylor's. So let me consider this. E power 1 by z. So we know the series for e power z, right? The series for e power z is 1 plus z square over 2 factorial plus z cube over 3 factorial plus z pi over 5 factorial and so on. So what will be for e power 1 by z? That will give me 1 plus 1 by z plus 1 by 2 factorial into z square plus 1 over 3 factorial into z cube and so on. We need to multiply by z even. So z power 1 by z equals z plus this gets cancelled. You get this, and then 1 upon 2 factorial into z will remain here, and plus 1 upon 3 factorial, and it will be z square and so on. Okay, and now to find out the residue of this function at z equal to 0, simply find out the coefficient of 1 upon z. Okay, it is we also call it to be b1. Okay, the coefficient of the 1 upon z minus alpha. Okay, that is the residue for this function. So here I get the residue. That means a residue of this f1 at z equals 0 will give me what? 1 by 2. So I found this one. And now I need the residue of this function at z equals 1. Okay, because this is analytic. So this is see what I am saying. You consider this function to be sum of three functions, f1, f2, and f3. So clearly this f2 is analytic, so this integration will be 0. So I'm worried about this f1, but integration of f1 is solved by residue theorem. I got 1 by 2, which I'll use it later, not now. And for this thing, there is a problem at z equal to 1. So I'll find out the residue. Okay, so a residue of f at z equals to 1 equal to limit z tends to 1. But now I see that it's a pole of order 1. Okay, so I just simply need to find out z minus 1 into f of z. So that will give me limit z tends to 1 and z minus 1 into 1 upon z minus 1 into z minus 3 square. Okay, z minus 3 square. So this part gets cancelled nicely, and I get here 1, 3 minus 1 will be 2, so I'll be getting 1 by 4. Okay, so I got two residues to be 1 by 2 and 1 by 4. Now, I know by Cauchy residue theorem that the integration of f of z is nothing but the 2 pi I times sum of all the residues. So I'll perform that trick now, and I'll erase everything. Okay, because I do no longer need them. So let's apply the Cauchy integral formula. So by Cauchy residue, okay, by Cauchy residue theorem, this integration, okay, all f of f, it will be simply 2 pi I times sum of residues. Okay, so that gives me 2 pi I times what I have is 1 by 2 plus 1 by 4. Okay, that is added. So that gives me, let me erase it first because I need to perform more operations in this problem because they haven't made it simple. So that gives me 2 pi I over, this will be 3 by 4. Okay. And when this gets cancelled, so I get 2 pi, 3 pi I by 2. So 3 pi I over 2. But what they have asked is this. 2 over pi I should be here. Okay. So we need to multiply this throughout by 2 by pi I. So if I multiply by 2 by pi I, okay, on both sides, I can nicely say that pi I over 2 getting cancelled and I get answer to be 3. Okay. So the answer is 3. Okay. And now let's consider this one, a bilinear transformation. Yeah. Okay. So it's saying t is from c infinity to c infinity. It's a bilinear transformation, so that t of 6 is 0. Okay. T of 6 is 0. And now what they have given that t of 3 minus 3i is I and t of 0 is infinity. So the image of this region will be what? Okay. What's going to be the image of this region? Okay. Under this mapping. Okay. Under which mapping? Because we don't have t right now. Okay. So there is one formula to construct t. You can consider this w equal to t of z equal to a z plus b over c z plus d, and find out a b c d. Okay, and substitute here to get the transformation. And in that transformation, you can just check with one single point. Okay, take any point which belongs to this domain and find out its image. Okay, and try to discard the options, because to deal with such kind of problems, it is better to discard the option instead of finding the correct one. Okay, so it's better to discard the options. But I'm not going to perform this entire operation because I'll construct a function which will satisfy this thing. Okay, because the problems which we are solving in this session are completely based on our approach. We haven't copied from anywhere. We do not follow any book. Okay, it's purely delivered approach, and we have made it. Okay, so I'll construct a function. So I need a function. When I input 6, that gives me 0. Okay, so that means t of z should be, t of 6 should be 0. That means I need here z minus 6, and when I put 0, it gives me infinity. So that means in the denominator it should be z. So this function is possible, or a reverse also can be happen. Reverse can also happen, right? And now if we look at this one, okay, t of 3 minus 3i, let us see if this satisfies or not. So t of 3 minus 3i will be what? 3 minus 3i minus 6 upon 3 minus 3i. Okay, so 3 minus 6 will give me minus 3, and minus 3i upon 3 minus 3i. Well, this does not give me I. Okay, it's not equal to I. That means this transformation is not valid. Okay, this transformation is not valid. Let's see if this second one works or not. Okay, if second one works, we will proceed with this. Okay, so what can I do here? T of 3 minus 3i. Let's substitute here. So 6 minus 3 minus 3i upon 3 minus 3i. Okay, does that work? So that gives me 6 minus 3 will give me 3, and plus 3i over 3 minus 3i. I think I made a mistake. Why it's not coming? Is there some problem? I think it's not working. I need to find out some other method, because I see that t of 3 minus I. Okay, that's why it is not giving me. Should I give me once again? T of 3 minus 3i is 6 minus 3 minus 3 upon 3 minus 3i. That is fine. 6 minus 3 will give me 3, minus plus 3i upon 3 minus 3i. But we know that this quantity will it give me I? Oh, wait a moment, let me see. is it giving me? So take 3 common and then 1 plus I over 1 minus I and just rationalize it. So 1 plus I over 1 minus I, and this 3 will get cancelled. So it will be 1 plus I square upon 1 minus I, 1 minus 1 plus I. So that will give me 1 plus 1, 2. And if you expand this, so you get 1 plus 2I minus 1 upon 2. So this 1 and 1 gets cancelled, 2 gets cancelled, you get I. Oh yes, we are correct. That gives me I. That means we have to work with this transformation. Okay. Because sometimes it is easy and convenient to find out the transformation rather than solving the entire problem. Okay, it is GATE examination and not your university examination. So you can think of a trick and apply any method that you know, because nobody is going to see what you have done. All they want is just final checked answer. So T of Z would be 6 minus Z over Z. So this is the transformation that we can work. And now we will take points one by one and discard all the options. So just let me consider 2 points. And now I'll simply just check any value here. Okay. So I just need to take a point which is lying inside this disk. So instead, can we take z equals to 2? Yes, 2 minus 3 minus 1, and it is less than 3. Yes, so 2 is lying in this domain. I just need to check the image for T of 2. So T of 2 will be 6 minus 2 upon 2. That gives me 6 minus 2 is 4 upon 2 will give me 2. So you see the image. This is the image, right? This is W. Okay. So this is your W basically. T of Z is W. Okay. So you got W equals to 2. And for 2, look at the option A. It is saying that imaginary part of W is negative. So wrong. Option B, it's saying the real part of W is negative. Here I'm getting real part of W to be 0. So option B is wrong. Now option C can't be set true right now at this moment because it is saying imaginary part of W is greater than 0. Oh, well, it is saying imaginary part of W greater than 0, but I got imaginary part to be equal to 0. That means C option is also wrong. So D is unconditionally right. Okay, no choice for D. It has to be correct. All right, so option D is correct. Now let's solve this one. 31. It says that you have two sequences, xn and yn be two sequences in complete metric space, so that dxn and dxn plus 1 is less than 1 upon n square, and dyn yn plus 1 is less than 1 upon n. Then they're asking xn is convergent or xn is divergent, yn is convergent, yn is divergent sequence. Okay, so just note, look at this result. Okay, the solution is here. I'll not use this space. So d of xn comma xn plus 1 is less than 1 over n square. So just you can consider this to be a sequence and find out the, say, an, okay, and just check the behavior of this series. Okay, check the behavior of this series. If the series is convergent, then xn will converge. Okay, if the series is convergent, xn will converge, and vice versa. If the series diverges, then yn will diverge. Okay, so that's a standard result that I'm using here. So 1 upon n square. Okay, so by p series test, it is convergent. Okay, because we know that series 1 upon n power p is convergent if p is greater than 1. So here p is 2. This implies this series is convergent. Okay, so we can conclude that xn is convergent. Okay, so here xn is convergent. And now talk for y. In the same manner, yn plus 1 is less than 1 over n. And again, take this to be the sequence. So take dyn and yn plus 1 is less than some bn, and inspect the behavior of the series bn. And that gives me series 1 over n, which is a harmonic series. Okay. And instead, if you take a p series test, and here p is equal to 1. Okay. So it is divergent. Okay. So it is divergent. So if the series is divergent, this implies the sequence yn will diverge. Yn will diverge. So you can take the option what you feel correct. Okay. So xn is convergent and yn is divergent. Okay. Now go for this one. 32 I haven't solved. 33. It says you have a function f from xy r2 to r, and its a function is sine of y square over x under root x square plus y square. Okay. Then add 0, 0. We have to inspect everything. Okay. So the solution goes here. So at x equal to 0, 0, instead I'll use polar coordinates. Okay, I'll use polar coordinates to find out the limit first, because there is a talk of continuity even. So I need to check, okay, if the function is continuous or not. Okay, so using polar coordinates, x equals r cos theta and y equals r sin theta. Okay, so as x comma y tends to 0 comma 0, your r will tend to 0, because you know that r is under root x square plus y square. Okay, that's why. So your limit becomes now in one variable, and you have limit r tends to 0. Okay, and you have sine of y square. That means I have r square sine square theta over x is what, r cos theta into r. Okay, now this r and r will nicely get cancelled, and I'll be having limit r tends to 0 r into sine of r sine square theta upon cos theta. And I know that this function is bounded. Okay, this is bounded and r tends to 0. That this implies this complete limit will go to 0. So we are also given that f at x equal to 0 is 0. So this implies f is continuous. Okay, that clearly means f is continuous. But from here, can we discard any option? Yes, option B. Option B is saying that f is not continuous, so B is incorrect. Okay, so f is continuous at 0, 0. Okay, and now they're also talking about the directional derivative. It is saying that f is continuous and directional derivatives of f does not exist in some direction. Okay, it is saying in some direction, and here it is saying f is not differentiable at 0, 0, and directional derivative exists in all direction. And in D, it is saying f is differentiable. So we will now inspect the differentiability. Okay, so for differentiability, I'll just consider the directional derivative first. Okay, if the directional derivative exists in all possible directions, then we can talk something about the differentiability. Okay, or we can even also check the partial derivatives. If the partial derivatives are not continuous at 0, 0, then function won't be differentiable. Okay, so let u equal to u1 comma u2 be any unit vector. Okay, so I need to find out directional derivative of f at p in the direction of u. Okay, the formula for this is limit h tends to 0 f of p plus h u minus f of p over h. Well, I'm short of space, so I need to erase it one by one, every step. So now let us find out this limit and see what is the conclusion that we get. Yeah. So it will be limit h tends to 0 f of my point p is 0, 0 and h into u. So that will give me h u1 comma h u2 minus f of p is 0. Okay. And upon h, that gives me limit h tends to 0 and f of, not f of, either we'll put now. So it will be sine of hu, so it will be h square u2 square over h u1 into under root of h square u1 square plus h square u2 square over h. Okay, and clearly this function has got no problem. Okay, this function has got no problem at all, and this h will get cancelled, because here from the root you can take h square outside and this h will get vanished with this h. So there is no problem with this limit. And now if you see, look at this limit, then sine of u2 square upon u1. Okay, but we know that u1 and u2 are the unit vectors. So what happens if u1 is 0? Okay, what happens if my first component is 0? Then this limit will not exist. That means directional derivative does not exist. But it is clearly said that, okay, I can't take first component to be 0. Okay, when I'm using this function. So u1 cannot be 0. That means this limit will exist for all. So sine of h will be 0. So this entire limit becomes 0. So that means directional derivative exists in all directions. Okay, directional derivative exists in all directions. Okay, so directional derivative exists. Now let us check differentiability. So for differentiability, we will first consider partial derivatives. So del f of del x at 0, 0. That will give me what? Limit h tends to 0, f of h comma 0 minus f of 0, 0 upon h. So what happens at this limit? That will give me limit h tends to 0. At the place of x, I have to keep h, and at the place of y, it will be 0. So just if I put here sine of 0 upon h into this quantity h square whole upon h, this entire quantity becomes 0 because of this quantity. Sine of 0 is perfect 0. So the first partial derivative exists. Okay, it will exist. Okay, so this equals to 0. Now del f over del y at 0, 0 will give me what? Limit k tends to 0 f of 0 comma k. Okay, times minus f of 0, 0 over k. And as soon as I come along this, now I'll be substituting 0 at the place of x. So since x is in the denominator, so this limit basically will not exist. Okay, so this limit will not exist. This limit will not exist. So if a function is differentiable, then its partial derivatives exist in all possible directions. Okay, but right now partial derivatives are not existing. That means my function is not differentiable. So f is differentiable option is gone. Okay, we know that a directional derivative exists in all possible directions. So even this option is gone. So remaining option is C, and this is true. So f is not differentiable and directional derivative exists in all possible directions. Okay, now look at this one. Very nice equation. It says if D be the region in R2 bounded by y square equal to 2x and the line y equal to x, then what is this integration? Well, just it's a double integration. So let us solve this. Y square equal to 2x. So 2x is right side of the parabola. Well, the diagram is not correct. Yeah, now it looks cool. And you have y equals to x. So let me draw that line. So this is my line y equal to x. Okay. We want the region bounded by parabola and the line. So that means we are talking about this region. Okay. So let us check what is this point. Okay. Since this is y equal to x, okay, y equal to x must be substituted here. So you get y square equal to 2x. That means x square equal to 2x. So that means please do not attempt to cancel 0, 0 from here. Instead, do this. Okay. So x into x minus 2 will give me 0. So x will be 0 and x will be 2. So when x is 0, you get y equal to 0. That is my origin. And when x is 2, I get y to be also 2. So that means this point is 2, 2. And all I need to do is just evaluate this integral by taking these two signs and evaluate it. So here I get double integration. This 3 will be outside x, y. And since dx, dy, so I need to first find out the limit for y. So y is moving from 0 to 2. Okay, I'm happy. And I need to consider now x. So how x is moving? So I see that x is moving, it's called as the parallel strip method. So I need to insert one strip in my diagram. Okay, so the strip which touches the region first, okay, the curve which is touched first by the strip is the parabola. So that gives me x to be y square over 2, and then it goes to x equal to y. Okay, so I just need to solve this integral. Okay, and I'm done. So let us solve this integral. So that will give me 3 outside and then 0 to 2. And here I have x will be here. Oh, no, y will be here because I'm integrating with respect to x. So y will be here and this x. So integration of x is x square over 2, and then from y square by 2 to y dy. So that will give me 3 by 2 over integral 0 to 2 y times y square minus y power 4 on 4 dy. Okay. So let's integrate them. So that 3 by 2 integration 0 to 2. Okay. And integrate a y cube minus y power 5 over 4 dy. Okay. So I'll write down the direct result directly. So 3 by 2. And then if I integrate y cube, then I'll be getting here y4, and it's 2 power 4 basically. Okay. So upper limit minus lower limit. Okay, every step is done here. It's 2 power 4 by 4. Okay, 2 power 4 is 4, and minus for this y, when I integrate, I get here basically 6 into 4. Okay, this 6 will come because of this integral, so y power 6, so 2 power 6. And now I'll multiply here by 6 and 6 just to make the bases same. So it is 24 and 2 power 4, and it is 2 power 6. Instead, I can take 2 power 5 common, and that will give me 3 by 2. Then I'll take in 2 power 5 common. So 3 minus 2 will give me 1 upon 24. Okay. And now that gives me 2 power 5. So this 2 and this 1 of 2 gets cancelled. 2 power 4 into 3. So that gives me 2 power 5 on 2 into 4. So this is 3, then this will make it 8. Okay. And since this is 8, 2 power 4 is 16 upon 8. Okay, that will give me 2. So the answer is 2. All right. Now let's solve this 35. It's saying that y1x is x cubed and y2x is x squared times mod x. And you are given that statement P and Q. P says that y1 and y2 are linearly independent solutions of this Cauchy Euler equation. And for Q, it is saying that Ronchian is 0. Okay, so let's consider. Okay, so if y1 and y2 are linearly independent, okay, if y1 and y2 are linearly independent solutions, okay, then this Ronchian won't be 0. Okay, so we just need to check what is the solution for this equation. Okay, what is the solution for this equation? So let us solve this. So I'll solve this Cauchy Euler equation. Minus 4x y dash plus 6y equal to 0. I hope you know how to solve a Cauchy Euler equation. So there is one substitution needed here. Okay, and since that put y equals log z. Okay, and now do all the manipulations and just write down here d into d minus 1 for x square terms, and for x into y dash it will be simply d, and for 6 it will be 0. And now if we solve this, then d square minus 5d, okay, minus d 4d plus 6 equals to 0. Okay, so that gives me d minus 2 and d minus 3 equals 0. Then I'll get solution in terms of z. So that gives me c1 e power 2z plus c2 e power 3z. Okay, so now let us resubstitute. Okay, let us resubstitute. I think I made the substitution wrong. Okay, z equal to log x is the substitution. Okay, not this. Now this will be correct. Okay, so z must be replaced with log x. Now let us resubstitute and see what we get in terms of x. So y of x will be equal to c1 e power, it's 2 log x plus c2 e power 3 log x. So that gives me c1 times this will be simply x square plus c2 times it will be x cube. Okay, this is my y of x. Okay, this is my y of x square and x cube. Yeah, notice this once again. See what I have is saying y1 is x cube and y2 is x square mod x. What we got here is something different. So that's fine. I'll keep this one. And instead I'll move forward to check this one. Okay, for this y1 and y2, let's check what is the Ronchian. Okay, so I'll do that here only, since I do not want to make what is of the that's good. Yep, so let's check the Ronchian for y1 and y2 and y1 dash y2 dash. Let me check. If this becomes 0, then I'm happy. So it is x cube and then x square times mod x, and derivative of x cube is 3x square, and x square into mod x is differentiable. Okay, and that too it is 2 times differentiable. So first derivative will exist, and that will give me x square into mod x will give me 3x mod x. Okay, and now if you take the derivative, determinant, so that will give me 3x square x4 mod x minus 3x4 mod x. So this determinant is 0. Okay, that means Ronchian is 0. That means Q option is true. Okay, So Q option is true. I need to worry about y1. Statement P. Okay. What is statement P? Okay, it is saying that, I'm sorry why I wrote P here. Okay, it's saying y1 and y2 are two linearly independent solutions. Okay, these two are linearly independent solutions. Okay, so instead of x square, they have given mod x also included here. So are they linearly independent? We need to check. Okay. So I'll consider two cases for this. Okay, I'll consider two cases. Suppose x is positive. Okay. Suppose x is positive, then what will be my y1? X cube. What will be my y2? It will be again x cube. Okay, so take the linear combination, c1 y1 plus c2 y2. So this implies c1 plus c2 times x cube equal to 0, but x cannot be 0. Okay, so this implies c1 plus c2 has to be 0. Okay, so in that case I get c1 equal to minus c2. So I'll call this equation 1, and now let x to be negative. Okay, take x to be negative, and if you take x negative, then you get c1 x cube, and this y2 is x square times mod x. That will give me minus times c2 x cube. Okay, so again you have c1 minus c2 when x cube equal to 0. So this implies c1 equal to c2. So if we just club these two equations and write it, c1 plus c2 equals 0 and c1 minus c2 equal to 0. So if you solve, you seriously get c1 equal to 0 and c2 equal to 0. So in the linear combination c1 and c2, both c1 and c2 are 0. This implies this y1 and y2 are two linearly independent solutions. That means even statement P is correct. Okay, even statement P is correct. So here A option will be true, that P and Q are both correct. Now let's solve this one. It says alpha and beta are the roots of this initial equation of this equation. So at x equal to -1, what will happen for alpha and for beta? Okay, so let me write down in this form first: y double dash plus p of x into y dash plus q of x into y equal to 0. First write down in this form. So I'll be getting y double dash plus x plus 1 upon x square minus 1. So that will give me x minus 1 square into x plus 1 square. Okay, into y dash plus q of x is minus 1. So it will be simply minus 1 upon, it's the same thing again, x minus 1 square into x plus 1 square times y equal to 0. So this quantity is p and this quantity is q. So I need to find out, and let me write down the initial equation for this is given by r into r minus 1 plus small pr plus q equal to 0. And what is this p and q? Okay, this is the capital P. Please be aware. Okay, this is capital P. The small p is nothing but limit of x tends to where they are asking at -1. So at x minus 1, it will be simply x plus 1 into capital P of x. The way you check your regular singular point, okay, it's the same thing. Okay, just find out that limit. Okay, that will serve as P, and the second one will serve as Q. Okay, so limit x tends to -1, it will be again x plus square into Q of x. So let us find out. If you put here limit x tends to -1, x plus 1. Okay, x plus 1. So x plus 1. Okay, in the numerator we already have x plus 1. So it will be x plus 1 square upon it's x minus 1 square into x plus 1 square. So this gets cancelled. When you put -1, you get 1 by 4. This is my P is 1 by 4. Now let us find out Q. And Q comes out to be, let me erase this because I don't need it. Q I'm solving here. So Q equal to limit x tends to -1 and x plus 1 square. So in the numerator there is no 1, so -1 times x plus 1 square upon x minus 1 square into x plus 1 square. That gives me -1 by 4. So I got two nice P and Q, and all I need is just substitute in this equation. Okay, in this equation. So let us see what we get. Instead, we will solve the same problem here itself. Yep. So r into r minus 1 and p is 1 by 4. So plus 1 by 4 r minus q is minus 1 by 4. So minus 1 by 4 equals 0. Just multiply it. So you get 4r square minus 4r plus r will give me minus 3r. Okay, it will be minus 3r minus 1 equals 0. And solving this will give me, once again, 4r square minus 3. So minus 4 is the factor. That means I'll be getting r plus 1 and r plus 1 will give me 4r. 4 into r. 4r minus 1. Oh, no, because this is negative. Negative. So r minus 1 and r 4r plus 1. Okay, equal to 0. So I'll be getting r equal to 1 and r equal to minus 1 by 4. Okay, so alpha and beta are the two roots. So initial roots, I've got this. Now they are saying that alpha is greater. So 1 is greater than minus 1 by 4. So alpha equal to 1 and beta is minus 1 by 4. So you got alpha minus 4 beta to be 1 minus 4 times minus 1 by 4. That gives me 2. So answer is 2. So the answer is 2. Now let's solve this one. And in S9, the group of all permutation of the set 1, 2, 3, 4, 5, 6, 7, 8, 9, then the total number of elements of S9 that commute with, okay, that commute with. So there is one direct formula for this. Just type here 1, 2, 3, and you have 4, 5, 6, 7, and just make sure that they are disjoint, okay? They are disjoint. So 1, 2, 3 are disjoint, 4, 5, 6, 7, and we see that 8 and 9 are, okay, going to itself. So now this is the complete cycle, and this is a cycle of length 3, cycle of length 4, and cycle of length 1. So we just need to find out, okay, n equal to, simply find out, there is only one cycle of length 3, so 3 into 1 factorial, okay, into 4 cycle also I have only 1, so into 1 factorial, and 1 cycle I have 2, so 1 power 2 into 2 factorial. Just multiply them, so you get 3 into 4 into 2. So 4 into 3, 12 into 2 will give me 24. So there are 24 elements in S9 that commute with this. Okay, so there is a direct formula. We just find out the length of the cycle and just raise to the power. Okay, how many times they appear in this cycle. Okay, and now let's solve this one. So let Q of X be the ring of polynomial over Q, then the total number of maximal ideal. Okay, so there is the again direct formula. So number of maximal ideal. So number of maximal ideal, okay, in Qx over x power n minus 1 is the number of divisors of n. So we need to find out tau of 4. Okay, so tau of 4 will be equal to what? It will be 2 square. Oh, basically, instead of writing all these things, number of divisors of 4 are 1, 2, and 4. So tau of 4 equal to 3. So there are 3 maximal ideals. Okay. So there are 3 maximal ideals. Now, let's see. Yeah, and from here, 39, 40, 41, 42, I haven't solved. Now let us solve 43. 43 is a Cauchy problem. So let's solve and see what is there in this Cauchy problem. Yeah, so they are saying ux be the solution of this thing. So compare it with this equation. So capital P into ux plus capital Q into ui equal to r. So apply your Lagrange method. So by Lagrange method, what do we get? Dx by P equal to dy over Q to dz over r. Since there is not z, it is u, so I'll use u. Now just substitute. So P is x, and dy over q is again y, and du on 4u. So just solve two pairs. So I'll consider first two pairs, and I'll be getting dx by x equal to dy over y. I'll simply integrate it and get this. Log x equals log y. Since these two are in log, so I'll take the constant even in log. So that gives me log x minus log y will give me log of x by y equals log c1. So this implies c1 equal to x over y. And now consider another pattern. So dy over y equals du over 4u. Now if you solve this, you get nicely, it's 4 times log y equal to log u plus, write down log c2. So it will be log of y over 4 over u equals to log c2. So that implies I get c2 equal to y to the power 4 on u. So I got c1 and c2. So the solution is given by phi of c1 equal to c2 or phi of c2 equal to c1. You can use either. Okay, so I'll use the first one because it looks simple. Okay, so phi of x by y equals y power 4 by u. I'll call this equation 1. Okay, now we need to find out the characteristic curve first. So to do that, we need to parameterize, okay, the equation of circle. Okay, so I'll parameterize this circle. It is saying x square plus y square equals, and u is 1. So u is 1, that is fixed, and parameterization of this circle will be simply cos theta and sin theta. Okay, it will be simply cos theta and sin theta. So now substitute here and see what phi gets changed to. Okay, so therefore phi of x is what? Cos theta upon y is sin theta. Okay, this will give me y power 4, that is sine to the power 4 theta upon u is 1. So it is fine, and this is phi of cot theta. That gives me sine to the power 4 theta. I need to change this variable, so I'll put cot theta equal to some tau. Not tau, I'll take t. Okay, so there is nothing in the denominator, I can take 1. And now I'll construct a triangle. Say I want to find out sine 4 theta in terms of t. Okay, so this is a right angle triangle, cot theta. Okay, so if I consider this angle to be theta, then cot theta will be 1 will be here and t will be here. Okay, and this side will be automatically 1 plus t square. Okay, so we got cot theta, and now from this angle we can also find out sine theta. So what will be sine theta? Sine theta will be opposite upon hypotenuse. So opposite is 1 and hypotenuse is 1 plus t square. Okay, so we got even sine theta. Now let me erase this thing. So this is no longer needed. So this goes away. I'll just keep this alive because I need it. So that means I'm getting phi of cot theta is t. So t equals to 1 upon under root 1 plus t square. That means if I put phi of x over y, so I'll be getting here, it will be simply y, no. 1 upon under root 1 plus x square over y square will give me y over 1 x square plus y square. This is what I'm getting. But seems, oh god, I have made a mistake here. God damn, this is not correct, because see, we got only sine theta, but here it is 4. Okay, so it will be 4 times, so that will make it 1 over 1 plus t square square. Okay, now let us find out. So phi of x over y will give me 1 on 1 plus x square over y square to the power square. That will make it y to the power 4 over x square plus y square to the power 2. Okay, now this is perfect. So now this is equation 2. Now equate 1 and 2. Equate 1 and 2. So you get y to the power 4 over u equal to y to the power 4 over x square plus y square square. Okay, from these two equations. Okay, their RHS are equal. Now this is gone. We no longer need it. And we see nice equation directly. U to be x square plus y square square. Now we want u of 2 comma 2. So u of 2 comma 2 will be 4 plus 4 square will make it 64. Okay, so answer is 64. Now let's solve this one. This is the Laplace equation in polar coordinates. So its solution is given by, I'll write down directly. Okay, u r theta is given by simply a0 over 2 plus summation n equals 1 to infinity r over a to the power n, and then an cos n theta plus bn sin n theta. So the solution is given by this. All right, solution is given by this equation. And now just one thing I wanted to check in the question paper. It is true or not, because I see some error. Yeah, it is 2 cos theta. So and now if you're wondering what is this a, then let me tell you this. A is 2. Okay, a is 2. And you are given here u of 2 comma theta to be cos square theta. Radius is 2, so that is fine. So this thing is nothing but my r. Okay, so I know that u of r comma theta is given to be cos square theta. So from here I just need to find out these coefficients. Okay, so can I write cos square theta in terms of cos by writing this 1 plus 1 by 2 cos 2 theta. And if you compare this equation, okay, from here, then clearly you get this is my a0. And remember, if I put n equal to 2, okay, if I'm putting n equal to 2, I'm getting this thing. Okay, so that means this will be my a2. So a2 is half. Okay, so I got a0 and a2. Now rewrite this equation again. Okay, rewrite this equation. So you get u r theta equals to, it will be 1 by 2 plus, it will be simply r square. Okay, because first term is 0. Okay, rest of them are 0. Let me write down here. A0, okay, equal to A3, equal to A5, A4, A5, all of them are 0. So A1 is also 0. Okay, A1 is also 0. So there is no A1. So I'll open this series and all of them will become 0. And since there is no Bn, so Bn is already 0. Okay, because there is no sign. Okay, in this form, there is no sign here. So just now equate r square over a is what? 2. Okay, so it will be 4. 2 square is 4, and then it will be cos 2 theta, and sorry, once again, it is a0 and then a1 times, sorry, a2 times cos 2 theta. Now let us write down a0 is 1 by 2 and r is we're not given. So write down here 4 and a2 is half and then cos 2 theta. So this is my u of r comma theta. What they want is u of 1 over pi by 2. So it will be half of r is 1. So it will be 1 by 8 and cos pi will be minus 1. So that will give me 1 by 2 minus 1 by 8. Okay. And u of 1 comma pi by 4, that will give me 1 by 2 plus again 1 by 8. And since this is cos cos of 2 pi by 4, that will give me cos pi by 2. So this quantity will give me 0. So it is again half. Okay, it will be again half. So now u of 1 comma pi by 2 plus u of 1 comma pi by 4. It will be simply half plus half minus 1 by 8 will give me 1 minus 1 by 8, which is 7 by 8. So answer is 7 by 8. Okay. Now 46 to 53 is statistics. So we haven't solved that. Now we will solve this transportation problem. So for this transportation problem, there are entries they have given. is this. So I hope you know how to solve a transportation problem. In case you do not know, watch this. So I'll solve this transportation problem by using Vogel's approximation method. Okay, also called as WAM method. Okay, Vogel's approximation. Because what they want is the optimal cost. Okay, they have asked for the optimal. So optimal value is given by the WAM method. Please do not apply northwest and least cost. Okay, we get a good solution. In fact, an optimal solution by WAM method, and it is confirmed by the UV method, also called as Modi method. Okay, this method will confirm that it is optimal, but we can give the solution in terms of by using WAM method. So I'll apply Vogel's approximation, and let's see how to apply Vogel. So instead, I'll just draw this random shape again because I need to perform certain operations. Oh God, this is insane. Once again, this matrix has to be there. Now let me draw. And now here, this is my destination, D, this is my origin, and this is the supply. Okay, supply is 20, 30, and 50. And the demand they have given is 10, 30, 60. And here I write down 4, 3, 6, 7, 10, 5, 8, 9, 7. Now what we have to do is find out the row penalty. Okay, find out the row penalty. So write down here row penalty 1 and write down here column penalty 1. And what is row penalty 1? Find out the least element of this row. Okay, least element of this row and the second least element of this row. So we see that least is 3 and the second is 4. So 4 minus 3 will give me 1. So this will be row penalty. And now here I see that least element is 5 and the second least is 7. So 7 minus 5 will give me 2. Okay. And for this, let's consider you have 7 and 8. So this will give me 1. So I got a row penalty even. Okay. And the same thing, it should be done here to find the column penalty. Find out the least element. So 4 and the second least is 7. So column penalty will be 3. And here you have 3 and the second least is 9. So column penalty will be 6. And here you have 5 and 6. So it will be simply 1. And now look for the maximum penalty where it is. Okay, whether in terms of column, in terms of row, just find out the maximum penalty. So I see that 6 is the maximum penalty. Okay, so you have to enter through this column, and find out the least element. So you see that the least element is 3. Okay, the least element is 3. Okay. The least element is 3. So to deal with this 3, let me use it. I need to assign the values. So you are given demand is 30 and supply is 20. Which of them is minimum? So 20. So I'll supply 20. I'll assign 20 to this 3. And from 20 minus 20, now supply is over. So this will be 0. And here 30 minus 20. So the new value will become 10. Now the demand is for the 10 because 20 is completed. So this row will be cancelled. This row will be cancelled. Okay. So again, we need to find out row penalty will remain same. Okay. Because there is no change in the row, but there will be new column penalty. So column penalty 2. Now the least element is 7 and 8. So you get 1. And then you have again 1 and 7 minus 5, you get 2. Okay. Now in this case, what we have is the least penalty, find out the maximum penalty. So here it is 2 and here also it is 2. So you can enter from here as well as here. So let us enter from downwards and see what we get. The least element is 5. Okay. And now I have to assign values to the 5. So for 5, the supply is 30 and demand is 60. So I'll supply 30 to 5. Okay. You have to supply the minimum one. And since this 30 is over, now 60 minus 30 will give me 30 and this column will get cancelled. Okay. This column will get cancelled. All right, so this column will be cancelled. And now what I'm having is, now let's find out the, of course, we have to enter from here, okay, to see what to get. So the least element is now 7. So 7 has to be assigned. This is 50, and in this column we have 30. So I'll assign here 30. 30 is assigned. What is remaining now? 50 minus 30 will make it 20. Now 20 is remaining, so the second element will be 8. Okay, second least is 8 now. Now the minimum is 8. So for 8, we have the demand to be 10. What went wrong? I'm sorry, something went wrong here. Yeah, and for 8, we have the demand for 10 and 20. So I need the minimum. So minimum will be 10 here. Okay, so 10 was supplied here, and now this 10 is utilized. So this 10 is utilized, and this 20 minus 10 will make it 10, and this 10 has to be assigned to this value. Okay, so now just take the multiplication of all the values. That means optimal cost will be equal to 3 into 20 plus 5 into 30 plus 7 into 30 plus 9 into 10 plus 8 into 10. Okay, if you add, you get 60 plus 150 plus 210 plus 90 plus 80. Together you get 21, 15, 60, 18, no, 9, 8, 17, 17 and 15. 32 and 6, 38 and 235 and 257 to 59. So ultimate cost is 590. So the answer is 590 is the optimal cost. Optimal cost is 590. Okay. Now, yeah. So let's solve 55. So I'm not writing the question. In fact, let me write down question number 55 here. Okay. So the question number 55 is, it says you have to maximize this LVP. So maximize kx1 plus 5x2 such that subjected to constraints are x1 plus x2 has to be less than or equal to 1, and 2x1 plus 3x2 has to be less than or equal to 1, and x1 and x2 are given to be greater than or equal to 0. And it is saying that x star equals x1 star comma x2 star is the optimal solution. Okay, optimal solution for k equal to 2. Okay, now this solution is optimal with k equal to 2. So what they want is the largest value of k. Okay, largest value of k for which the solution remains optimal. For which the solution remains optimal is what? All right. So now let us consider this region and plot it. So x1 plus x2 is less than 1. That's fine. I'll take it here. And 2x1. So that means I'll be getting this region. Okay. All of them are less than or equal to 1. So this will be my region. Okay. But the actual is this. Okay. We want the intersection is this region. So this point is from half comma 0. And this point is 0 comma 1 by 3. Okay. 0 comma 1 by 3. Now let us find out. Z at 0, 0, it will give me 0. And z at half comma 0 will give me k over 2. Okay. And z at 0 comma 1 by 3 will give me 5 over 3. We want the solution is optimal. That means we are, the problem was to maximize. That means the maximum value should be optimal for k, right? K equal to 2 is giving me maximum. So that means we want this value, that is k by 2 must be greater than 5 by 3, because it is saying the solution is optimal. So that means k by 2 must be maximum for any k. So k by 2 is greater than 5 by 3. So this implies k is greater than 10 by 3. So this implies k is greater than 3.333. Okay. So k is, optimal value of k is 3.333. So that was all about gate 2017. Thanks for joining, and we will solve GATE 2018 in our next video. Thank you so much, and thanks for watching.